I would like to let you know that we have, unfortunately, I have to have this microphone on my ears, so sorry about that. And I have to read it because I was taking another exam from other people before that, and I didn't have time to have some anything. So, excuse my, accept my apologies for this. There is a sample midterm exam on the Canvas. You have 200 minutes time to solve it, and this sample midterm exam is exactly as you will, exactly as similar to what you will have in your midterm. Every questions here you will have another similar question in the midterm exam. You understand what I'm saying? So if you have 3 normalization questions, you will have 3 normalization questions. If you have 1 ERD question, the format of the question may be different, but if the question is multiple choice, then the question will be multiple choice. But a bit different. No, let me see. Some of the questions are not exactly similar, but the difficulty of the exam is exactly similar to what you see in this sample midterm. A bit might be your exam will be a little bit less difficult because this is the sample, but just go and work on it. It was 200 minutes I put 200 minutes for this sample midterm exam, but 200 minutes is too much, and you will have just 1 hour to solve this midterm exam. Okay. If I see that there are a few people took the sample midterm exam as an exam a few minutes ago. If I see the results, and then I may drop a few questions out of that. I realize that some people cannot completely solve the question, so I may need to drop some questions, but the number of questions are very small because we have just 3 or 4 SQL questions, 1 trigger, 2 indexing question, and 1 normalization question, 3 normalization question, and 1 ERD. Okay, and except 1 or 2 normalization question, all of the other questions are in formal problems. You are given a query, or you are given a trigger, and you are expected to explain what that query means or what that expression means, or you need to guess, or you need to recognize the task that you are doing. This is the sample midterm exam you are supposed to do, and it's very and also the sample midterm exam is a homework. The deadline for the sample midterm exam will be 1 hour, just 1 hour before the final midterm exam. It means that on Thursday, 2 p.m., the deadline for this homework. Okay, do it and try your best, and you have plenty of time. 200 minutes is too much for this exam. And you can ask these people if the exam was easy or not.
Very easy. Easy.
So, not even 1 mark.
All gone.
No, but they are kidding.
Don't expect to pass it. All gone. 10 out of 31, 13 out of 31, 15 out of 31.
నాది ఇంకా ఇక్కడ సాఫ్ట్వేర్ పని చేయట్లేదు.
How many questions did you solve? Did you get to the end of the exam or not?
We submitted.
Submitted.
We don't know what.
Hopefully we get for what. We will start query processing. So far, we discussed about indexing structures and physical structures. You know what different indexes are. You know what B plus 3 is, and also you know different types of hash indexing. Now, from now on, we will go through query processing and see how DBMS systems are answering questions. Query processing is important in practice because if you do not have any sense how queries are processed, how queries are responded, then you will not be able to write a good and well-performing query. So Before starting the query processing, we know that the main action in the data, when you are processing data, is sorting, right? So far we learned that, for example, in range queries, if we have our data sorted, then that will be a great advancement, and that will be great fortunate for us when we are processing range queries, when we have select queries and range queries, okay? So sorting is very important, but the problem is when you have databases, the size of data is very large. So data cannot be fitted inside of the main memory. So then we need to, then the sort algorithms we learned in algorithm class may not be very helpful. Or we need to change those algorithms in order to make them working for our case when we have large data. So then we need to combine basically those memory sorting algorithms with some smart techniques of minimizing I/O in order to make the I/O and from the disk and page transfers as less as possible. So the first sorting algorithm we use, and the main sorting algorithm used in database systems is called external sorting. But why do we call it external sorting? Because it's not happening inside of the memory. We are using disk in order to sort our data. Okay, for example, suppose that you have a very big table and you want to sort it. Okay, it's not going to fit in the memory. Therefore, we need to do your sorting outside of the memory and on the disk. So there are two main components for external sorting. The first component is computation of the sort inside of the memory. Okay, wherever we want to sort and whatever we want to sort, basically we need to sort data rows. Doesn't matter where we are doing, but in order to do the sort, you cannot compare records on the disk, right? You have to take all of the part that you want to sort, or some part of the data we want to sort, to memory and then sort it. So the main one of the components is computation of the sort inside of the memory for some part of the large data. The other part is the other component is the I/O. We need to switch this data from the disk to main memory and switch back when we sorted from the main memory to the disk, right? So we take the data from the disk unsorted, some part of it, bring it to the main memory, run the sort algorithm, maybe the sort algorithm we learned, traditional sort algorithm we learned in algorithm class. Then when the sorting is done, then we have to write it back. Okay, this is the I/O is another component of the sorting algorithm. So, okay, so let's consider a simple sort algorithm. Okay, suppose that we have m number of main memory page buffers. It means that we have our main memory can fit at least m number of pages inside of it, and the size of the file is f. The file has f number of pages. Okay, so how do we sort this data? And definitely f is larger than m. Do you remember merge sort?
Yeah.
How many phases merge sort had? How many phases? Merge sort has two phases. One phase is sorting some part of the data. The other part is merging it, right? So the similar idea applies here. Hold on, I should save this first. so the similar idea happens here. So we need to bring some part of the data inside of the memory, sort it, and then put it on the disk. And then the second phase, we need to bring them from the disk and merge them. So suppose that in order to do the first part, okay, in order to complete the first part of merge sort, how many page transfer do we need? How many page transfer do we need? I mentioned a few moments ago.
Can you repeat the question one more time?
In order to sort before merging some part of the data or different parts of the data, how many page transfer do we need? M or F? At least, eventually these pages should come to the memory, right? So we need F, at least F page transfers, right? So what we are doing is we move these chunks of data, parts of the main data to the main memory, sort it, and each time we are creating a sorted part of data. What is the sorted what is the number of the pages we are sorting in this part for each run, for each sort? No, we are how many parts will be sorted? How many segments will we have? Sorted segments. What?
F by M segments.
F by M, yes. Because the whole thing is F, and each M chunks of the data is sorted. Okay, we'll have F by M sorted runs, and the cost is for this the first phase we have F number of page transfers to bring them to memory. We need to also write it back to the disk, and we need another F number of transfers to write them to the disk. So we need also then in total we need to have 2 F number of page transfers. Okay. So after sorting each run, then we need to merge them. Okay. So we need to we have we have the capacity of keeping m number of pages in the memory. Okay. If you want to merge it, how do you utilize this memory? In order to merge, you need at least one page to write the output. Okay. How was the merge sort? If you have two-way merge sort, you are taking two sorted components and then compare the first element of each one, and then if whatever is less, then you put it inside of the output and proceeding until the chunk is finished, right? Both of the chunks are finished. So similar to that, we'll have, if we want to have more than 2 ways of merging, how many chunks we can have? How many pages do we need? What? Suppose that we need to. Let me explain the problem this way. We have m number of the capacity of keeping pages inside of the memory. You need one of them for the output. The rest could be used for the inputs, right? Then you can have m minus 1 number of the pages participating in the merge, right? Mm-hmm. So instead of merging 2-way merge sort, you can have m minus 1 merge sort. So in this case, So again, what's the cost of this? What is the cost of this? Why 2F?
Transferring
Eventually, every data item should be in the memory, and eventually every data item should be written to this. Okay, it should be then, nothing will be decreased. Okay, so here is an example of merge sort. I'm not gonna, I'm sure that you all know about merge sort. So, let's talk about the merging phase, cost of the merging phase. So, how many merge steps we need to take for if we have n number of n-way merging? What is the order of the algorithm, merge sort algorithm? When you have n-way sorting, n-way merging. N multiplied to log n to the base of n, right? So similar to this, you will have here same answer. So let's get back to this slide. How many chunks we have? How many components this merge has? This merge is n minus one way merge, right? So what is the size of each run? What is the size of each run?
2 pages.
F divided by m.
But at a time it can start only 2 page. Only m page at a time.
What do you mean m page?
F by m. At a time it can start only a single page, then go to does it sequence.
I didn't get the suggestion. I can suggest you can come over and discuss about your idea.
No, at a time it can do only m, right? Not f by m.
Why?
Because it goes like sorting should do it sequence and then.
Eventually, you have how many sorted runs you have?
Okay.
You have
then it
f by m,
yeah.
right? So this f by m, how many times you run this k? This f by m will be eventually come to the after k merge steps, they will be sorted. Okay, what is the k merge of steps? M minus 1 over of k. So this k here, I have technology over here. This k here is equal to this one. This number of steps is required to merge an initial set of f by m sorted runs. Okay. So the total cost of the merge sort will be 2f multiplied to log f to the base of m minus 1 minus 1. Okay, this is the and total cost is almost 2f log m minus 1 to f. By the way, how many people have checked the videos I put on Canvas? And which videos did you check? The videos that I used?
The triggers and
triggers.
Oh, okay. But a few number of people just checked. Either you are busy or you are not interested. How many people check videos? No, a lot of people. Good. Okay. The other important component when we are processing queries is duplicate elimination. Why? Duplicate elimination is a part of many of the SQL query processing operations. For example, for projection, or when you are projecting some information and you are supposed to remove duplicates, or for union, for set difference, and all of those stuff. Okay, so hold on. The problem, the interruption is because I'm recording for all DL students on the other laptop, and I'm using a software that I don't have the license, and it's a trial version, and every 10 minutes I have to resave the file, and that's why, sorry for the interruption. So, okay, so duplicate elimination is, duplicate elimination is important, okay? So, what are the techniques you can use for duplicate elimination?
Sort and delete.
Suppose that you have an array and you want to remove the duplicates.
Distinct.
What is the best way?
Having unique values or something.
That's what distinct.
No, this is just forget about the database. This is an algorithm question. You have a big array and you want to
Hash map.
exactly hash map. If you use hash, then this is the fastest way to remove duplicates. Okay, but here we cannot use. But in database, I will talk about limitations of hash map. But in database, there are other techniques that are more useful, and maybe hash map has some limitations. Maybe sometimes it's very helpful, but in our case, we can also use other techniques. The traditional technique or the naive solution for this problem is sorting. Okay, you sort the data, and then you pass through the array. You compare each pair of the consecutive items, and if they are equal, one of them should be removed. A few minutes ago we talked about merge sort. So when we are merging, we also can remove duplicates at the end of the last step. Why? When we are merging and we are comparing n minus
Sorted
1
values.
buckets, what we are doing is at the last step we just remove. We see if we see any duplicates, just ignore the data item. So in this case, removing duplicates doesn't have any additional cost. Okay. This is an example of you can remove duplicates in merge. Okay, now let's talk about projection. Okay, suppose that you are supposed to have a select query to show some part of a table, some specific number of columns, not the whole columns from the table. Okay. In order to, and also you need to sort the data, or if you don't need to sort the data, also you may need to remove duplicates. Okay, if you want to remove duplicates, we learned how we can remove duplicates. The technique we used was sorting or merge sort. Okay. So for sort-based projection, what we need to do is the first step is we need to sort. Okay. For sorting, what we are supposed to do. So consider that f number of pages you had in the disk. When you are reading from the disk, okay,
F by M chunks.
some of the unwanted columns should be ignored when you are reading it from the disk, right? So then when you are reading this, when the size of the data will be decreased, then with more efficient algorithm you can sort it, the rest of it, and then remove the duplicates. And the whole thing is, the cost of the whole algorithm is because of the sorting. Okay, now the solution Krishna provided to us, hash-based projection. So how does it work? Don't think about database, think about algorithm. You are given a very large array and you want to remove duplicates using hash function. Which is a very common question.
Hash function will give you like a particular row or particular point. So if we have 2 points particularly, so we can able to remove one.
You have a hash set, okay? Whatever you start reading from the array, and you put whatever you read in the hash set. If the hash set already has the data item, then you do not need to add it. So you automatically ignore that record that is duplicated. So similar to what we had in the sorting, first we need to read the rows and then ignore the rest of the columns that we know we do not need it. Okay. Then we can hash the remaining part of it. One more question. Here, what happens if we do not remove the rest of the columns?
Where?
In the hash-based projection. The second step is project out columns, right? It means that ignore unwanted columns.
Yeah, they will also get sorted out.
What?
They will also get sorted. We don't know.
No,
Two
you are
values
using
will have the same
you are
ID.
using your algorithm. Okay. The data you need to remove the duplicate is only the columns that you are interested in, right? The rest of the columns are not interesting.
Yeah.
So what you are doing is, if you do not remove the rest of the columns, okay, then two records may have one pair of duplicate records may have two different hash values because there are some other column values that you are not interested in those columns, but they are participating in the hash function, right? So what you are doing is you are giving the whole row to the hash function, right? So if the whole row contains the unwanted columns, then the hash value will be different from the case that the hash function receives only wanted columns, okay? So the algorithm cannot work. So removing or eliminating unwanted column is essential for this algorithm. Everyone understands what I'm saying? Who needs more explanation? Who needs more explanation? Everyone is okay. Okay. So, after removing unwanted columns, we can hash each column we read to the range of n-1 pages. Why? Why this is the range? How hash set works in Java? I need to leave. I need to. This is how hash set works. You have hash function, okay? You get the item, you fill a hash function. There will be hash value marks in the hash set going to check, saying that this guy is now existing. Okay? So we go through, if duplicate happens, then when you get the hash value and go to the set, you will see that the checkmark is existing. Otherwise, you check to the hash set. Okay? So what is the range of the hash function? In order to make this algorithm working, what is the range of the hash function?
All the elements without duplicates.
What is the possible range for us?
Yes.
As much as we can fit in the memory, we can work with that. Okay.
Yep.
Okay. Then, in order to utilize as much as possible all of hold on, I should. Then here, similar to this case, we have in the databases. What was the size of the memory we have? We could fit n-1 pages or buckets inside of the memory. Okay. So the range of the hash function we choose is as much as we can. Okay. Then we go through and we hash the values we get from the wanted columns to memory and mark it. Okay. Now, so what is the phase 2? The phase 1 was getting values, marking into the hash set. Second phase, when you mark in the hash set, then you need to, there are some buckets in the hash set saved. The hash entries are saved in the hash set. Okay, so you need to remove duplicates. Okay, by sorting or by marking it as a met information. So here we got we have this input file. We get this input file chunk by chunk here. We use the hash function. We use the hash function. Each bucket is created. How many buckets do we have? n-1. Okay. This is the hash table we have. Okay. So each of these n-1 buckets shows that which rows should be selected and put out. Okay. So then what we need to do is we need to search these, sort these buckets and write the information back to the disk. So is that clear for everyone? What was the problem, the main problem? What was the projection? What was the projection?
The unwanted columns.
You have to remove unwanted columns and you have to
Remove duplicates and unwanted columns and put it outside, okay? So we read the rows, then we remove the unwanted columns, then we hashed into n- buckets, okay? And now, how much was the cost? Each bucket, when you hash it on the bucket, then you put the bucket on the disk, right? So the buckets are the list of the pages, the list of the data file, the list of the data files, so again saved on the disk. How many reads and write we are doing?
4 times.
12. Once eventually every row should be read from the disk. Remove the unwanted things and all this processing, no page transfer. After putting them in the hash map, then putting outside. Okay. So the phase 2 of the hash sort is for each of the buckets we have to sort the data. So because we know that the data items fill in one bucket shares one set of values, right? So if we sort it, then we are done. Okay, the whole thing will be sorted. So for the sorting this m number of the buckets, how many redesign rights we need? We need again read the buckets from the disk and write it to the disk. Okay, it's 2f. Okay, so now let's review what we have for the.
Professor, then using hash, the cost is more when using hash, is it, compared to merge and sum?
For the sorting, because in the sorting you are doing some part of it based on, so here you need to, hash is not good for sorting, okay? We are removing we are eliminating duplicates and also we are sorting, okay? The second part, if you, okay, so in order to remove eliminates, what's the cost? 2f, okay? So in order to sort, what's the cost? Another 12, okay? First you put buckets, sorted, shared buckets with the value, and then you put them and sort it, okay? So if you do not need to sort it, what's the whole cost?
2f.
If you do not to sort it, what is the whole cost with the sort? Again?
2f.
No. It's, sorry, I have two computers. It's more than 2f. But if you are supposed to sort and you are sorting, then with the sorting, elimination of duplicates and sorting happens in the same step. Then you do not add any 2f, any other 2f. Okay? Then hash-based projection, when you are required to sort, is not very good. But if you are not required to sort, and when you write back those m number of buckets and you are done, then that hash-based projection is good. Okay, so let's have some review on indexes we have. So suppose that now we want to compute selections. We want to compute selections in process algebra we have. In relational algebra we have. So if there is no index on attribute and we want to select something, okay? So if rows are not sorted based on that attribute, what we are supposed to do?
Sort them.
What? No, we are select. We don't need to select. We don't need to sort it. We are supposed to just set it outside.
No index is not. If it is
No index is,
primary.
yeah, and the condition is some operation, some comparison relation. What is your solution?
Question number.
The file is not sorted. You don't have any index. You have a very big file. You have a file, and you want to find some elements in that. What are you doing?
Going one by one on file.
Going one by one, scanning the whole file, right? What's the cost?
F.
F. So if rows are sorted based on that attribute, and the operation is either equal to or any other range operations, what's the cost?
B tree, that's log.
The cost of the binary search.
Binary search.
What's the cost of binary search? Log of f to the base of log of f to the base of 2. Okay, so doesn't matter if it is the operation is equal or greater than or less than. If equal search is happening or range search is happening, what you are supposed to do is when you just need to find the first element, and after that, based on the operation, you have to scan and find the rest of the reports, because we know that the file is sorted. Now suppose that we are using p plus 3. Okay. So what are you doing when you want to respond to this type of queries?
Which type of queries?
Selection.
We'll get the index and then we'll start ranging from what the values we require. The linked list will traverse.
So what was the cost of searching using b plus 3 index? The height of the tree, right? The tree and the tree was balanced. We know that the height is constant for every leaf node, okay? So first, any type of search, either equality search or range search you have, what you are doing is and you know that the index is clustered. What does it mean?
Index is?
The index is clustered. What does it mean? Clustered and non-clustered. You have midterm next week. Some people gave midterm now. Clustered and non-clustered.
It's arranged or is
Clustered index was those indexes that the data rows also sorted based on the index entry,
it's sorted.
based on the index attribute. Okay? So if the index B plus 3 index is sorted, for example, we have attribute ATTR, and there is a B plus 3 cluster index for this attribute. Then we know that records also on the data file also sorted based on this attribute. Okay, so what is the cost? First, locate the record on the file, and then go through and find all the records matching that condition. For this purpose, if it's a range query, you have to just you have to process the rest of the files until the time that you see that someone is not matching or meeting the condition. Okay, so there is a sorted file. The only cost is finding the first element. The rest is just scanning and retrieving. Okay, the whole cost of the retrieving information, the whole cost is
Retrieving is just just reading the data. We're just reading the
very
data.
difficult task. Every 10 minutes I have to. Okay, so suppose that this is a B plus 3 graph, okay? And these are like a linked list. And this is the file. These are pages. Okay, the records are there. What you are doing, you got a search key or a boundary for a range search. Start from here, going through and find the boundary. Okay, then this part of the index has a pointer to the main file, right? So what else? What are you supposed to do?
Retrieving.
I'm done with the index. Go and retrieve pages. See if who is matching the condition. Since it's sorted based on the same key, then I'm just retrieving pages until I find out that I'm done. Okay. So what is the cost? The number of the pages that contain the rows with the satisfying condition. Okay. It means that the cost will be the number of pages, okay, containing satisfying condition rows. Okay. Okay, now suppose that B plus 3 is, we have a B plus 3 index on that attribute, but it is not clustered. Okay, so what is the algorithm? What is the cost? Cost of the search is similar to what we had before. The depth of the, you start from the root, go, and find it. And if the whole index is fitted in the main memory, then the cost of the search in the index is just one page transfer, nothing else. What is the rest? So what are the indexing trees? Each indexing tree is a pair of attribute value and also a pointer to the file. Okay? So let's get back. So what am I doing here? Suppose it's a range search. What am I doing here? Well, I found the index here. Okay. The index is, for example, pointing to somewhere here. Okay. Now, can I go and read the pages and why?
It's not clustered.
It's not clustered, then it's not sorted based on that. Okay. So the assumption is gone. So what we are doing is, but we know that the leaves of the B plus 3 are sorted. So I'm not going again to search next value, just traversing this linked list in order to find a row, an entry that is not matching or is not satisfying the condition. Okay? So from here to here, there are all pointers. Okay? So these are pointing to some places in the file. Okay? So what we are supposed to do?
We have to get the pointer and read from the file. Get the pointer, read from the file.
Okay.
Till
So
the
Fanindra is suggesting that whenever we read a pointer, just read the page file. Is that good? Fanindra, don't rush. Read all the pointers and sort them. Okay? Maybe some of the pages are not required to be retrieved. Okay? Just retrieve those page files that has a pointer to them and matching satisfying the condition, right?
No, from this pointer to that pointer, we are traversing through the pointers.
So you traverse through the pointers and find all the pointers that are pointing to the main file, okay? These are page files. Okay.
So what is the value located in the file? That's what we require, right?
Yes, but in order to read any value, you have to read the whole page file. The page file is the minimum unit of reading and writing to the file, right? So if you have 3 pointers to here, okay, then if you read it once, it's okay. You read this page file once, take all those 3 and put them inside the memory, select them inside the memory, and then go to the next page file. So again, with this technique, what is the cost? So we scan the V plus 3. We scan all the indexing trees. Each indexing tree has a record ID pointing to the place that record is existing in the file. Okay, we sort these record IDs and we recognize that which pages are supposed to be retrieved. Okay? Then just need to retrieve the pages. So what is the cost? What is the worst cost, worst case cost? Since it is not sorted,
Worst case is all the pointers
all the pointers are different pages.
different page, then that's the worst
So
case.
it could be
Max will be
the whole,
points.
the whole, uh, the whole file. So the cost is basically, you can say that the cost is the number of the rows satisfying the selection condition. This is the picture that site has. Okay, now let's use hashing. So we want to hash, use hashing. So what are you doing? What was the cost of the hash index?
Well,
Cost of finding an entry in the hash index?
1.
1, okay? So suppose that the hash index is clustered. One question. Can hash index be clustered or not?
Can
What?
No, it cannot be.
Why?
It can be, but
It can be.
It can be.
For example, you have the hash index for primary key. You sort the file based on the primary key, but the hash index is also based on primary key. So then what you are doing is first, you need to find the boundary of the search or the selection search. When you find it, what happens? What happens when you find it?
We initially find the record. Directly.
What?
When we find the key, we initially find the record.
As soon as you find it, since it is clustered, the rest of the operation is going through main file, reading page by page, and see who is matching the condition and retrieving it. Okay? So if it is not clustered, it's not clustered, what happens?
We have to come back again. We have to get to one more index.
So if it is not clustered, it means that the row IDs you are finding for each index is not, it may not be consecutively located on the file. So what you are doing is you retrieve the IDs and then sorting it, similar to what we did for clustering on cluster, and then recognize which pages should be retrieved, and also then we will retrieve the pages. The access path is a bit longer. I cannot finish it today. I would rather to go and do a simple practice. How does it sound? Better? Unfortunately, we don't have HDMI to VGA converter, and Finance computer is very slow. So I would rather to work with my school. So
Inside computer.
what was it?
Nothing, perhaps.
Okay. Okay, we have this employees database that you have had asked questions in the exam, right?
Yeah.
And I guess you loved it. Questions were really good. Solve this problem, please, or at least try to solve it. You have 5 minutes or 3 minutes to write the simple query.
Why? Hard query is 1 minute, 2 minutes.
So this is
Time is not much.
5 minutes. 5 minutes is good, right? These are the tables we have. So, first of all, I want to write a simple query to find out who is that person, that lucky person managing this research department. Okay. I just need his employment ID number.
No, we can directly do joint site question. Instead, we can
No,
directly
I
do
want to go step by step. What was this? Going on.
పనికి రాదు అది సార్ మీరు ఏమో చేశాను నేను సో మళ్ళీ నేను ఇంకా ఏం ఇన్స్టాల్ చేయలేదు
కొత్త ల్యాప్టాప్ చూస్తుంది కదా అందుకే చెప్తారు సిస్టమ్ రీసెంట్గా పెట్టాలంటే మీకు సాఫ్ట్వేర్స్ అన్నీ చేస్తుంది ఓన్లీ సాఫ్ట్వేర్స్ స్కూల్స్ ఇంగ్లీష్లో సిస్టమ్ బూట్స్ తీసుకుంటే
సో ఫైల్స్ ఉంటాయి సాఫ్ట్వేర్ మొత్తం అందుకే స్క్రీన్ కనిపిస్తుంది
ఒకటే కదా అది చిత్రం చేయాలి ఓడి మంచిగా ఉంటాడు
So, which one is the guy? Who is the manager?
5 people.
If two date is, if I select the second one is the guy, right? The due date is 99, 99/01/01. Okay, so I will put this one also. Okay, this is the guy. Okay, now.
Can we put greater than current date? Date is greater than current date.
Yeah,
Today is greater than
he will be the current manager.
right. Today. But the current date is current date is similar to, because here we know that this database is this one.
Yeah, I mean.
We are writing queries for lifetime. Okay. Department manager. Okay. This is giving this. Now, what we are supposed to do is we have to go and count what number of rows we have in from salaries. Times.
No, 14 times.
I mean,
Because you have to remove one row because changing, right?
Oh, I
It
see.
changes only
The
14
last time. The last time also changed, right?
no, the first time is not changing.
First time is not changing, right?
First time is just
current row.
Oh yeah, the first time. So that the first time is the zero. They are feeling
No,
zero.
if there are 10 rows, the salary change is only 10 times. 9 times.
I know, but you know, this okay. 15 is also acceptable. So this is the number. If we want to make Inkada happy,
Current manager
we will do -1, right? Are you happy, Inkada? Okay. So, because if the first time he's not changing his money, his salary is changing. Okay, so is that simple or not?
This is simple process. What you gave in exam, more than one simple query.
Only one query is simple.
Only one query process. Remaining everything for each query, it is taking almost 15 minutes process to write. The thing you have given like max count like salary changes for department manager, that has a subquery process, like two subqueries is there for each query. Like to write that, it's very difficult.
Write subqueries, you just write subqueries.
No, inside subquery inside subquery, and then subquery inside like 3 subqueries.
Okay, so you know how to solve it.
No, but time is not enough, professor. That too, we took exam only for 15 minutes, professor, not 1 hour also. That is also a problem. If there was more time, we would have solved something and we would have answered to this. But there is no enough time also. Last 2 queries we didn't see professor. Like what the query we didn't read even the query.
Queries or questions?
Questions and queries both, professor. We went till 7. That's it, professor. Like after 7 we didn't see anything.
Yeah. Did you solve the index questions?
Yeah. No, I solved, but in the last while submitting, accidentally I clicked wrong answer and I submitted. You switched off the lights and you were saying submit. We submitted.
The guy was getting to the room, no?
No, but even we wrote only exam for 15 minutes. We didn't even write for 1 hour.
Oh, it was very.
No, sir. I mean that, but it takes more time, sir. Queries are easy, but they are taking more time to solve, sir. That's the problem. They're taking more time to solve. This query we solved it in under 2 minutes, sir. But those queries what you gave in exam, those are difficult.
Remember what? We just need to check to see. But I remember that yesterday night, when I was writing the questions, I was solving it by myself.
No, you can solve because
2
the
a.m.
idea is the idea.
All the difficulties, when cold.
No, but it's easy only, because I am not saying it's difficult, but they're taking more time, but time is the constraint.
Yeah, okay, I will decrease the number of questions for next people. Sorry. You were.
We are the laboratory.
We'll write again. We'll cancel our plans.
Extra marks.
Extra marks.
We could put one.